Are you guys all here? Almost all of you? Now look at you. Nice looking group of people. Okay, well, we have our friends from BV, and I'll let you guys introduce yourself here to bring to you an opportunity to work at their firm, guys. So I'm not going to steal their show. I'll let you guys introduce yourself. And do you mind if I take a couple of pictures while you're doing that? Good? Okay. Oh, we need, it would be nice if we present, if you guys see what we're doing on the screen, right? All right. Come on, it's coming. There you go. Okay, so here you go. So go ahead, guys.
All right, well, we're here with Black & Veatch, an engineering firm based out of Kansas City, but we have an office here in Bloomington now, opened 2 years ago, I believe. Katie and I both work in Bloomington. I have an AAS degree in Civil Technology and Surveying from St. Paul Tech, and I started out working at a private engineering firm doing subdivision work, and now I'm working with the energy group in the electrical field for the last 6 years. And I'll let Katie introduce herself as well.
Yeah, I'm an electrical engineer. I graduated from Michigan State University, and I've been with Black & Veatch ever since. I've kind of traveled through a couple different divisions and done some different things from generation all the way to our division does here, which is power distribution, and we'll kind of get more into that.
So I guess as far as the overview here, we just want to explain to you what Black & Veatch is. You know, we're a growing company, what we do in the power delivery group, and how the energy is a growing industry. Our office in Bloomington, and how we're trying to grow our presence here in the Midwest, and that we're here to recruit, drafters, CAD experience, the softwares we use, typical things we do. We're going to have a lot of plans and slides and stuff for you to look at, transmission drawings, substation, and all that stuff, site photos and good stuff.
So this is kind of an overview of, I'm sure what we discussed is the electrical grid, starting from the power plant where the power is produced, then it goes through transmission substations, as well as high voltage transmission lines to a power substation, and then more to your distribution lines that all the way to the consumer's house or commercial industrial places. So power delivery within Black & Veatch is the portions up here. So we primarily cover the ways that it gets to people that use the power. So we have clients from that are using utilities, and we're developing drawings and specifications to build those pieces of the electrical grid. And we kind of break that down a little bit more, but just when we talk about power delivery, this is the portion, everything from the power plant out is what we deal with before you get to the distribution level.
Yeah, and then we have a little video here that our HR group created for us. It's pretty neat, so we'll show you that as well.
For over a century, the transmission grid has been the backbone of the electric power industry. With the integration of new generation sources and smart grid technologies, as well as the effects of evolving technologies into this aging infrastructure, there are more demands facing the grid than ever before. For decades, Black & Veatch has provided our clients with creative solutions needed to overcome these complex and ever-increasing challenges. With power delivery offices nationwide, we have the local resources to quickly respond to our clients' needs. Black & Veatch provides enhanced coordination and communication, as well as a thorough knowledge of regional challenges, enabling us to tailor innovative and cost-effective solutions. Our clients rely on us to provide services for every step of the project lifecycle, from project development to engineering through construction and asset management. We offer both union and open shop construction solutions, as well as construction management services, all while maintaining an industry-leading safety record. Black & Veatch's power delivery expertise is extensive. We provide and implement creative ideas to ensure reliability and meet cost and schedule requirements for overhead and underground transmission lines, as well as gas and air-insulated substations. We have successfully completed HVDC, SVC, voltage and bar projects, performed power system studies, and supported the integration of renewable energy and smart grid technologies. At Black & Veatch, we maximize our clients' resources with our comprehensive project and program management solutions. The success of our projects is the result of our close working relationship with our clients. We strive to be a trusted partner, customizing our solutions and service offerings to each client's unique needs. Black & Veatch's experience is broad and varied. As an industry leader, we are consistently ranked among the highest for transmission and distribution in engineering news records publications. We have the expertise to provide our clients with the results they need time and again.
So that was kind of a lot of information there in that video, but it's good to kind of see all the photos and stuff of like the transmission lines and substations and everything that we kind of worked on. As the video mentioned too, we're in the top 500 in a lot of categories as far as you know, all the fields that we do at Black & Veatch. Power is our group and we're ranked 3rd, so doing pretty well in that category. Here's just like a brief overview of the company. These numbers probably need to be updated for 2013, but like, you know, we have over 10,000 employees worldwide, 110 offices. Our revenues were 3.3 billion. It's a really big company, but when you'll see in these future slides that we're located throughout the entire world. As far as like a small office field, that's kind of like what we have in Bloomington. Our group is like 27 people right now. So even though we work for a bigger company, we all know each other pretty well. And kind of a nice feel. Here you can see the energy group is what we're involved in, and it's a very, very big chunk of our company's financials. And we just want to like reiterate how good the energy field is doing.
You can kind of see we touch on mostly all, I guess, utilities. So telecom utilities, water utilities, and then the other federal and consulting for utilities. So we're dealing much more with a very stable industry.
So here's the regional office we have throughout the U.S. We're located in, I believe, 29 states. So there's a lot of opportunity, you know, to bounce around and kind of move around and go where you want to go. And then we also have a really big global presence. We're trying to, our goal here now is to like balance our workload. So everything's not top heavy in like the U.S. We're trying to balance out where our work is in other countries as well too, to kind of ride out any rough times the economy may bring.
So this is kind of different portions of energy that we're involved in. So beyond just power delivery, which we already talked about with what we do, we touch on the generation of coal using oil and gas, nuclear, combustion turbines, and or renewable energy. So those are the pieces of the company that we don't necessarily deal with, but we'll delve into power delivery a little bit more.
So yeah, here's the power delivery slides then that we have.
Yeah. So there's a lot of acronyms, different kind of technology. Basically, whatever our clients want us to do. So we win a lot of different projects. A lot of them in our office we're working with, we'll get to later, are out in the East Coast. So there are a lot of compact substations that need to connect the electrical grid. So when you need to put things close together, you're not using coated wire, you're using bare cable that are running the transmission lines. So in order to do that in a small space, they actually have different technologies to do that. So gas insulated switchgear, when you can put gas around it instead of plastic, and so you can put things a lot closer together. So we're dealing with technologies like that, installing either that or air insulated switchgear, but again, integrating all these different types of things for our clients in many different areas.
Yeah, using like smart grid technologies and things too. You know, the renewables is a big push nowadays as well. So these are all things our office is involved with. Here's our power delivery offices throughout the U.S. Of course, we're located in Bloomington or the Minneapolis office, but we do work across offices on our projects to get things done, you know, on time and in budget. So we just wanted to kind of show you the different areas that our power delivery offices are located. Here's our current staff in the Bloomington office. We have our project manager, Eric Fife, for the substation group. We have 13 engineers underneath him and 3 technicians, along with a project support admin person.
Technicians are people like Tony that do drafting as well as designing. There's I think different, but the career path for technicians or drafters at Black and Beach can vary depending on organization. I mean, I know people that have been at Black and Beach for 20 years and continue to just do drafting, and then others that have moved into designing conduit routing plans or grounding, or I mean, you can probably speak to that a little bit more, but the path of
Yeah, definitely, and I want to touch on that a little more later too. But like, there's just a lot of opportunity, like to as much as you kind of want to learn and put into it, you can make your steps, and there's also like you can move from a technician to a designer role as well too inside the company. And then Eric Brzezinski is our transmission line engineer, and he has 9 engineers under him and 1 engineering technician. Here's our client list that we've been working with here recently. So as far as in the area, we've been working with Minnesota Power and Excel Energy. And then, as Katie was saying, the big company that we work with out east is PSE&G. And then our transmission group works a lot with American Transmission Company. As far as the CAD softwares we use, mainly the utility companies use a lot of Bentley or MicroStation VAI. It's really similar to AutoCAD in functionality, but it's just a little different, like clicking buttons and whatnot. We'll use AutoCAD depending on the client, and then the Autodesk Civil 3D is kind of like when we get into the civil drawings and the grading plans and things like that. We'll use that to do dirt calculations and things like that for the project site. And also PLS CAD is also a software that they use for transmission line planning, and I got some more slides here coming up on that. So this is from a project that the transmission side did. It was a 45-mile corridor of brand new lines that had to go out and do all the planning and routing and right-of-way acquisitions and just everything that goes into the process of like engineering a new transmission line like that. So then here you'll see the PLS CAD models that they use. It can generate these profile views. You can see the tin here with the topographic map. It's like the roadway here with a clover leaf, and then here's all your wires and transmission lines and stuff. So the software, you can use that to generate all that kind of stuff. And then also in PLS CAD, you can do like plan and profile sheets, like the one on the left there. This was a line re-rate project, so they basically went in and got all the topographic information and made sure that none of the lines from over the years were sagging too low for like clearance issues or anything. If they were, they might replace a pole, or they may regrade some dirt or whatever it took to correct the problem. And then, so that's kind of just a brief overview of like the transmission section things, and then we're going to the substation here. We have 3 types of drawings in substations. We kind of have like the civil package, the electrical package, which is like your physical stuff, all the steel, the equipment, whether it's outdoor or indoor equipment, and then the controls, which you guys know controls like all the operations of the systems. So here's like a standard grading plan. Kind of see the site's graded out relatively flat, and everything just kind of slopes away real gradually. So that way, when they build the substation, you don't have too much grade change for all your equipment, that you don't have to do a bunch of steps or anything on like a rigid bus and things like that. Ponding, tree clearing, grading the slopes, things like that. It's a relatively pretty simple grading plan. You have your standard notes and things here. You have a legend. border, standard border, and everything, north arrows. So that's kind of where the plan gets kicked off then. And then this is just another grading plan, I guess. The first one was in MicroStation, this one was in AutoCAD. So just kind of want to show a little bit of the difference there, I guess. And then here's some grading details. You have like the section for the pad, what they would call the pad, where all the substation equipment is located. You have your trench details for pipes and conduits and flared end sections and things for the driveway. So it's just kind of want to show the standard details of what we would put together for that. And then you have the erosion control plan, which looks quite a bit like the grading plan, but like along here, this is probably like an area that we're going to seed, and we're showing like seeding or blanketing, riprap, things like that, check dams, you know, all your erosions type stuff. This shows just the details that you'd have. You have your silt fence details over there, and just some like your rock check dams and things like that, construction entrance. This here is the next step then would be getting the foundations all set up on a plan. So you kind of see like we lay out all the foundations, we dimension them, get the fence in there, the driveway, kind of show everything as far as a overhead plan for the foundations and where they'll go, and so they can get staked and put in the proper spot. Here's a kind of a typical slab detail for some piece of equipment, probably a breaker or something. You can see the rebar and stuff in the concrete. So you have your concrete slab, you have your anchor bolts. Here's all the section that they would clean out and put good select fill in there. You have your top view. It's all detailed out, like where the anchor bolts would go and stuff like that. And then once you get your foundation details created, then you can move on to like your drilled piers. That's for like the smaller equipment with stands. You'd either have a drilled pier or a spread footing. And spread footings have some coming up here, but basically the drilled piers, you know, there's different diameters, different bolt patterns, kind of has different ones on there, and your anchor bolt cage details. It's all in the chart for the sizes and how much rebar and all that are in that chart then. And then we have a steel setting plan. This is like basically an overhead plan of like where all the steel structures will go and kind of what they look like from the top view. But here again, you can see they're all dimensioned and called out. So then each one then has its own separate steel detail. And then here's a kind of a standard steel detail. This for a switch stand. But it's just basically the same types of things, calling out all your materials, dimensioning everything, where the bolt holes will go, where everything will connect up. General notes, design, criterias for loading, and then this here was a foundation plan for a GIS hall that we have some pictures of and stuff coming up, so I just wanted to throw this in the slide so you can kind of see the area. It doesn't come out the greatest, but the GIS hall is like right here, and we'll show you some pictures
So that's
and stuff.
indoor, and this is all outdoor with all those kind of similar foundations that we showed before.
Yep, so like all that equipment's on the outside and that's on the inside. And here's just a zoomed in view of that GIS hall. It kind of has some trenches in here for the control cables and stuff to run, and I'll show you in the picture here. It gets a lot better. And then here's that spread footing that I was talking about. You can kind of see that it has the bottom piece here, that this piece will be underground then, and then you have like the raised pier. So in this view, if you're looking from the top, this is what would be buried, and these would be exposed, which are above grade for this equipment stands to sit on. And as you can see there, quite a bit of detailing, you know, letting the contractor know where all the rebars are going to go, and like where the anchor bolts all need to be, things like that. So here's that same site that I showed you the grading plan of. It's just rough graded out here and getting ready to start to pour the foundations and things like that. There's your spread footing. You can see this is the piece here that will be buried underground then. So that was in the detail. And then this is like the raised portion of the pier that'll be above grade for the equipment to mount to. So here's that GIS hall, and it has the troughs here for the cables to run in. I think also they do that when they pour that, it's for so they don't have to pour so much at one time. I think this took 3 days to pour, I believe.
Continuous concrete truss.
Yeah, it was non-stop. So here's the finished slab for the GIS hall, and you can kind of see some of those spread footings and stuff in place. They're being ready to be poured, framed up. Ones are showing you over there, partially poured.
That's the important part.
Yeah, now the good stuff.
So this is just putting all the equipment where they put all the foundation. So just kind of touch on what the drafter designer does. Basically, they're directly responsible for creating all of these drawings. So they work with an engineer or a team of engineers directly to figure out where to put every single thing to maintain all the plant requirements and all the clearances necessary. I know that it's definitely a learning process between the two. So you can see kind of how things are spaced and detailed out. These drawings are given to a contractor or to a fabricator. Every single piece on here that needs to be built or procured, this needs to spell it out so that you can build what you're going to see in a few minutes. So this is a section plan. All of these little circles pointing to a piece of equipment that we're either fabricating or purchasing. And then there's another bill of materials table that will show every piece detailed out. But yes, this is the building that the foundation that they poured is going to go on. And then each one of these little blocks here are those spread footings that were poured by the cells.
And then there's that GIS hall that we showed you the photos of. And then if you go back here, you can kind of see like the overhead of like all the equipment then that's in that GIS hall. And that, as Katie said earlier, is due to like the size of the site. They need to contain that all in that room. It's much more costly to build a GIS hall, but it's more efficient land-wise. So like out east, they're using them quite a bit for like available space.
Can you go back 1 second? The spacing here that's required between the it would actually move and touch it. Oh, that's funny. So the spacing that you see here, I mean, obviously it's not necessarily, you can't see the dimension, but this is a ABC phase of like 3-phase. It's a 500 kV yard. So that is if you look at these two lines right here, that's all the spacing that's required when you have gas in between. So just to understand the scale, it's in like I don't even know, a fifth of the scale when you put gas in between. So this would have to be 5 times as large if you had continued air insulated versus gas insulated. I can touch it. So this is a picture overview on top of the building actually. You can see that this is the bus that they're putting in. So it's like rigid conductor. So because it's 500 kV and it's a lot more current going through it, just a lot bigger than this. So it's, I believe, 4-inch bus. So it'll be kind of like what it would come through on the inside of your electricity. But these are the big A-frames that were used. The strain busted, the flexible conductor that is being strung from tower to tower that's going to land here and then come down to land on the rigid bus.
So then that's like the line, that's the transmission line heading out of the site then to go to like the next substation. And then like Kay said, the conductor will drop down into this equipment. And there's some more slides coming up to show that as well.
This is the inside, so you can see the gas insulated switch gears is blue stuff, so A, B, C phase. I'm not sure what trailer it is in this one, but there's breakers, there's switches, there's a bunch of other configurations. So basically they can connect the grid in a bunch of different ways. In case there's an outage in one area, they can kind of switch the way the power flows between the grid. So then that's basically what the electrical department or drawings cover, and this will be what the controls drawings will cover. Probably a little more to do with what you did. I didn't include a lot of the schedules of the panels that will actually specify breaker sizing, and we'll do all of the breaker sizing. lay everything out and then have someone else purchase it. But these are the racks that are actually go inside the control building, or the control room, and this will have all of the pieces that the client wants to control something. So this is to open or close these giant breakers and gas sensing switch gear, to measure or to read the current or the voltage at a different place in the So this is what it looks like in real life. So we sent that previous drawing to the manufacturer actually down at Iowa, and then this is what the client wants. If they want it green, they want it this big or whatever. So they meet all the specifications that we showed on the previous slide, and this is what gets installed. So there's a bunch of them getting ready to ship to the site. So this particular job we actually had to build because at GAX Hall, so that we built it on site and we had to ship there and installed once they got there. And then this is a schematic, so it actually shows which switches close to energize the relay that's going to protect all of the equipment. So in case there's a big voltage spike, it'll tell which breaker to open, or if there's a outage or a down power line or something, it'll kind of control how everything interacts with each other. And this is not coming out as well, but this is a wiring diagram. So you have the physical layout, then you'll have the schematic, and then this actually shows the electrician which conductor of each cable to go on each terminal in order to make all of that schematic work. So we will produce these and work with the designer to make sure everything gets drafted accurately, the circuit schedule, everything kind of corresponds to each other and works. This is how they look installed, or as they're being installed. So the electricians get up there. These are the terminal blocks they're landing all the wires on. This is a project that we turned around, I believe, in just a year, I think, to produce all of the, maybe less than a year, so 6 months to produce all the drawings, and construction took about 9 months. So a pretty massive job for us, but.
And this particular project too, it was the EPC, which is engineering, procuring, and construction. Our company also has a construction firm that they own, so we'll do like EPC projects where we do all 3 phases, and that's what this project was.
So we had somebody on site that was overseeing the electrical contractors that were installing every piece of the equipment that we specified. Just the front of the racks, you can see how many there were in order to control that large of a substation. And this is the final picture, just showing the building complete, the yard kind of layout complete. And
then here, this side, they got the conductors in there. So they drop down into the equipment.
So, kind of an overview of what we do, but we wanted to kind of give you guys the drawings and pictures, give you a better idea of what we do. We're looking for people that are excited about the energy industry and that want to be a part of a growing company, a growing office, and good future.
Definitely, yeah. And I mean, like competitive in compensation and benefits. We have a 401k match. We're an employee-owned company, so however hard we work and how well the company does, it definitely benefits us. Career development, we have things in place, for training, and we have sponsors for like when we have new employees hired on, so someone works with them to train them in. We have career development plans that we all fill out and kind of, you say, here's what I want to do, and you go after it. And there's definitely a lot of opportunity to move up. There's, I believe, 10 levels alone for like the engineering technician group, and then you can move like into designer group, and there's multiple levels there too. We have flexible hours. We have different schedules that you can work. We have like a 980 program where you can do 4 9s and an 8, and then you get 4 9s the next week and have that Friday or Monday off. So it's very, very nice there too. Stress the global opportunities. Some people will take like a 5-year stint and go work in like another country to kind of get another office fired up and help get things going, and then they'll kind of come back and go back to their current role or whatever. So there's cool opportunities like that. The energy field is it's a great field to be in right now, with everything is, power demand is going up. Maintenance still needs to be done. They neglected the grid for a while, and it's costing them now, you know, and getting things back up and to the right thing. I guess as far as our office location, we're in Bloomington on 494 in France. Our building's pretty nice. We have a cafeteria right in the building, so that's pretty convenient. There's a bank, an ATM, all that. We have free parking. There's also a gym in our building, so a lot of nice, you know, little benefits and things like that that are kind of nice.
That's all we had to cover. But if you guys have any questions, we'd love to hear more from you guys.
Let me just mention one little thing that we have 4 students right now from the previous years that's doing the same work that you guys are doing. 2 of them for Excel Energy. So you are trained to do this type of work, of course, as an entry level, and then you build into it. So you know,
And we're throwing a lot of information. You know, we just want you guys to see like what we do, and it's a lot of stuff. And it's taken me years to get to the point where I've worked on all them different things. So it's not something you're gonna learn like in 1 year's time. So.
And this is something we don't expect any entry-level engineer or designer to be able to do any of this stuff. We train people ground up, so it's you spend, you know, one-on-one attention with an experienced designer or an engineer, explaining how to do everything. You don't have to know MicroStation, or you can do both CAD experience and be able to be a self-starter and take initiative, but yet, you know, take direction well from an experienced person.
so how can they contact you?
Well, as far as contacting, there's
I think
email or
I think I forwarded you that email that has like a link to the job rec, but then there was also other information on there as well.
Okay.
So that's the best way to go about it, is to enter, you know, in on that, and then that'll all get into our HR system and then get forwarded on to us.
Okay.
I mean, you can, if you have a resume today, want to go to us, we'll take that. If you want to email us a resume, we'll take it that way. We have to have you apply online because we have to work with the government. There's rules and laws and things like that. We have to open it for the way we take applications. So it's bb.com/careers, and then there's a requisition for, I believe it's designers, right?
It's engineering technician, I believe, and I sent you the link for that, so
follow
you
that
can
requisition,
forward
fill
that
it all
on.
out. And then you can specify your preferences on location, so just make sure you say Bloomington if you really want this, but hey, if you really want to go to California, we have offices there. If you really want to go to Florida or Texas.
someone in Orlando.
Yes.
Yeah, there is one in Orlando.
Down to the warm
North Carolina, I think.
Yeah, let me tell you that we are hiring worldwide, and I think our corporate goals for 2020 are to leave double in size or something.
Yeah, it's really aggressive, like how much they want to grow. So we would definitely like you to come work with us, but if you need to go to Florida, that's all right too. And we will be at the career fair on Thursday morning too. So if you don't have your resume today, if you want to tune it up for then and hand it to us or whatever, you know, that works great too. But definitely, if you're interested in a position, I would recommend, you know, even if you're interested in like internship type thing, I would recommend filling out for that as well. So.
Any questions? Well, thank you.
Yeah, absolutely.
Thank you guys. I'll forward the information to you. And you guys are going to be here tomorrow.
Yes, we will be here tomorrow, so yes.
That'll be awesome.
Can you tell me any other questions? Yeah. Say that again?
You guys have any questions? I don't know if you can work to the class.
Yeah, good, thank you.
Yeah, thank you guys.
Yep.
Oh boy.